Hi friends, welcome to our YouTube channel RF Design Basics. In this video I am going to design a 50 ohm microstrip line. First of all, we will calculate the width of the line by using online calculator. You can find the link for online calculator in the description. We will put all the parameters here in this online calculator. We are using FR4 substrate. Dielectric constant for FR4 substrate is 4.4. So here we will put 4.4. And height for FR4 substrate is 1.6 mm. This is height. So 1.6 mm. And frequency we will take at 5 gigahertz. We are designing a 50 ohm line, so Z0 will be 50 ohm. Electrical length we will take as 90 degree, but we can take any length as characteristic impedance doesn't depend on the length of the line. So we'll click on synthesize. It will give width and length of this is width and this is length. So width and length of the microstrip line. So we get approx 3 mm width and the length 8 mm. We can take any length since the characteristic impedance will not depend on the length. We have to take this 3 mm width. Let's go to HFSS. Now insert the HFSS design. We need three things here: one ground, one substrate box, and one top plane. So first of all, we will insert one 2D plane, that is rectangle, to design ground. We will start from the origin and move in X and Y direction. This is ground. We can rename here. We can change color from here. And by clicking on create rectangle, we can control the dimension of the rectangle. I have started from origin, so starting position is showing 0, 0, 0. I am taking the rectangle of size 20 cross 40. So X size I am taking as 20 mm and Y size I am taking as 40 mm. Okay. Click on this icon, it will fit the view in a window. Now we need to design the box for the substrate. So here click on the draw box, and again, since we are designing the same size box, we'll start from 0, 0, 0 and we'll move in X and Y direction, in XY plane and in Z direction. This will give us box. Click on box 1 and rename it as substrate. And material, since we are using FR4, we will change it to FR4 here. Click on vacuum and go to edit. Type here FR4. FR for epoxy comes, click OK. Now click on create box, and we have started our design from 0 0 0. So this is starting position, and X size is 20 mm, Y size is 40 mm, and height of the substrate is 1.6 mm. So Z size will be 1.6. Now we will design our microstrip line on the top of the substrate. So start drawing by taking on rectangle and designing it on the top of the substrate. Click on this rectangle and name it as line. Change the color. Now for changing the dimensions, click on create rectangle, and since we are making it on the top of the substrate and middle of the substrate, so this starting point will be x will be 10 minus 1.5 and y will be 0 and z will be 1.6. X size is 3 mm since the width of the line is 3 mm, and Y size will be 40 mm. In this way we get the line, our substrate and ground. This is our substrate, this is ground, and this is line. We can rotate it and see it. This is our ground in different color. This is our substrate in this different color, and the top of the substrate microstrip line. We have assigned material to the substrate, that is FR for epoxy, but we have not assigned material to ground and line. This ground and line will be of copper material, and copper material is a perfect electric conductor, and we can't assign material to 2D planes. So we will assign boundary, perfect electric conductor boundary, to these two planes. Click on ground and control and line. So we have selected these two, and right click on any one and go to assign boundary and click on perfect E. So in this way it will assign perfect E to both planes. Click OK. We can check it from here. Go to this HFSS design, and in boundaries just check, it will show perfect E1. Click on this. So what are the boundaries it will show. Okay. After assigning boundaries, we'll give excitation. This is two port structures. One port will be here, and another port will be this side here. So for designing ports, we need to give two rectangles in the XZ plane. This is X and this is Z. Just zoom it and change the plane to XZ, ZX. Take one rectangle and draw it here, connecting the microstrip line to the ground. So this is port 1. Change its name. Double click on this and change its name. Port 1. Click on create rectangle, and this is starting from 8.5 and 0 and 1.6, and this X size will be 3, and the width of the microstrip line we have taken is 3 mm, so we'll change it to 3 mm, and Z size will be 1 minus 1.6. That is okay. Now we will assign port to the this rectangle. Click on this rectangle, or we can select it from here also. Click on this port 1 and right click here. Go to assign excitation. There are several ports available here. We will use here lumped port. Click on lump port. Make sure this is 50 ohm. This is name 1, port 1. Impedance is 50 ohm. So next, and here click on none and select new line. Click on the upper line here where this triangle comes. Click on that point on the triangle. In same way, come to the lower plane and move your cursor on the lower line, and where this triangle comes, click on that point. This window will pop up. Give next and finish. In this way your first port is ready. You can see the excitation from here. This is your port 1. Now we will design port 2. So rotate this structure from here to the other side of the line, and in same way design a rectangle of the same size as we did. Click on this one and change this to port 2 and click on create rectangle. Change this X size to -3. This is okay, and select this rectangle, right click on this, assign excitation, lump port, 50 ohm line, next new line, click on the triangle, then again click on the triangle, and next this will give you port 2. Rotate this structure. So we can see both the ports from here. This is 1 and this is 2. So given the excitation, we need to give a radiation box that contain the whole structure. So radiation box should be bigger than our design or our structure. Now we'll start designing the radiation box by clicking on this draw box, and We have changed this plane to XY plane and start drawing from here, moving XY plane and in Z direction. So we have designed one box. This box should be bigger than our structure. Click on this box and rename it as red box. Assign air material to this box. Go to edit, type it air and OK. We'll change the transparency of this block because we'll not be able to see this see our design when transparency is 0. So we'll make the transparency as 1. We'll make this structure transparent. Okay. Now the design is visible, and go to create box. We can control the dimensions from here. We have to take box bigger than a structure, so I am taking the initial points as -10, -10 and -20. I'm extending X to 40 mm, Y to 60 mm and Z to 40 mm. Click here to fit the view. So this is our structure, final structure. Now we'll assign radiation boundary to this radiation box. So click on red box, right click on red box and assign boundary and go to radiation, this radiation boundary. Click OK. We can see the boundaries from here. This is perfect electric conductor and this is radiation boundary. So we have designed our microstrip line and given all the boundaries and given both excitation port 1 and port 2. Now we will give analysis setup for our design. So right click on the analysis and go to add solution setup. Set this solution frequency as 5 GHz and click OK. Again right click on setup and go to add frequency sweep. Click on this and choose this interpolating sweep type, change it to fast and give a start point as 1 GHz, stop point I am taking as 20 GHz and step size is 0.1 GHz. Okay, click on display. Okay, so we have given our setup for the simulation. Now I will validate the design by clicking on validate option. So everything is okay. Our design is validated. Now close this window and now we will run our structure. This will simulate and will give the results. Now simulation is completed. We'll see our results. Right click on result and go to create model solution data report and click on rectangular plot. So it will give options to plot these parameters. We will choose S parameter and we'll choose from here in second option S11, S12, S21, S22 everything, and here in function we'll choose dB. Now click on new report. So this will show S11, S12, S21 and S22. These are S11 and S22. So S11 and S22 are less than minus 10 dB. Is in fact less than minus 20 dB because both the ports are matched, and S21 and S12 both are around 1 or 0 dB. Since in dB it will be 0 dB, since transmission is lossless, and in higher frequency this loss is increasing. So this is our final result, and here we will in this lecture we'll design something new in our next video. Thank you.